All right, looks like we're live now. Okay, so this stream, I'm going to be continuing the development of Linux Air Combat, which I've been working on for the past couple of weeks. And last week, I set up this very basic rendering backend for OpenGL. And the only thing that this system renders right now is this triangle. So for this stream, I'm going to continue developing this so we can actually load mesh data and have not just a hard-coded triangle in the data, or in the render output. So that means we need to continue developing the render backend, write the model loader, or port the model loader over from what was previously existing, and then load that into this OpenGL program so we can display it. All right, so let's get started on this. Let's see, so the triangle that I was just displaying on the screen is just hard-coded into the screen, or hard-coded into this mesh right now. There's no data, so it's just triangle with very simple coordinates. There's no 3D projection, no file access yet. So actually, first thing I need to do is actually continue writing this function, because we have a function to load a mesh right here, but we need a way to unload a mesh later on so that we can destroy mesh objects. So I need to add a couple of functions. Okay, so the way I'm storing renderer specific data is kind of clunky, but I'm just going to continue going down this path because I don't know how else to abstract this. So right now this is storing render data and a void pointer. This specifically, right now it's going to be storing OpenGL mesh, which just holds the data of an OpenGL vertex array object. That gets loaded during this load mesh function on the OpenGL backend. So we need to add a new function to unload a mesh. What's up, Fosgrees? Looking forward to this. Oh, nice. Yeah, I remember you from last time. Yeah, I'm just going to continue developing this. Hopefully I don't get data errors like I did, well, like last time when I couldn't figure out what was causing this OpenGL data to be corrupted. Okay, so that means we need a way to actually call this when the mesh object is destroyed. So that means we also need to add a destructor to the mesh. And we need to store a pointer to a render backend. And we need to add a way to populate the render backend. Okay, I'm just going to forward declare this class because I really don't want to pay the compile time price of having to include this file. Okay, so something needs to call set render backend, which passes the pointer to the renderer, and then in the mesh destructor, we need to actually check if render backend and the mesh data is set, or render data. Check the render backend and render data is set, and then call the appropriate destruction functions using this data. That means we actually need to add the function here. So wait, it's unload mesh. That's the function we need to call. So m render backend unload mesh. Okay, so now that we have this function, we need to actually call the set render backend, which we can do here. Okay, I think the inheritance doesn't work properly with this for declaration. Wait. Oh, that's why. I didn't actually inherit from this. Okay, there we go. Okay, so this populates the render backend in the mesh object. Then we can call unload mesh. And really the only work that needs to be done here is calling, well, to create the mesh, we need to call gen vertex arrays and gen buffers. So to destroy the mesh, we just need to call the appropriate delete vertex array. That means we actually need to fetch the mesh data. From the mesh object. So this returns a void pointer. We need to cast it. Okay, I'm not sure if static cast is the correct cast to use here, if we're storing it as a void pointer. We may need to use a dynamic cast. I don't remember the rules for that. Yeah, so this is not a safe way to do this, but I could not think of a better way to actually store the mesh data in the mesh object without following this pattern. So anyways, we need to destroy the vertex object array, and we need to destroy all the buffers inside the object. Oh, this function call already takes an array, so we don't actually need to do this loop. Okay, so it takes this GL size I, which is actually a type of int. I mean, I guess C++ handles those int downcasts automatically, but no, let's just add a static cast there. Oh, okay, so because I actually set the inheritance here, I need to start marking these as overrides. What? Okay, I don't remember this rule either. Oh, that's why. Okay, so this mesh is marked as non-const, and also this is marked as const, but that doesn't match the function signature here. There we go. I don't know if this actually needs to be const. This compiled fine. So I think keeping this const here is fine, even though we are modifying the mesh. We should probably just delete that anyways. Yeah, we need to add the other override specifiers. Okay, that should build. And now we have the mesh that unloads when the mesh object is destroyed. So that doesn't actually have an effect on our program here, except, okay, we can test whether or not we actually hit this, this point in the mesh. So we can set a breakpoint here and see if it hits. There we go. So now we are destroying these objects. And it looks like it executed successfully. Okay. Okay, so we have the system to create and destroy meshes. Now we need a way to actually load real mesh data into the program. And Linux Air Combat already comes with a mesh loader, which is called 3ds.h. This isn't the best API, but it should be. I mean, I think it's already correct in how it loads the meshes. The main issue is that it uses a lot of types that depend on like vector threes or matrices that are defined specific to Linux Air Combat. Okay, it's in the model.h folder. So this is what I mean. We have C color, which is just a 4-byte color 4-byte color type. We have texture, C vector 3. It depends on all of these types, and I want to replace these with the like GLM types instead of these custom ones. So I think for now I'm going to start by just like copying the 3ds file into a new file, so we can modify that file while leaving the 3ds untouched in the Linux Air Combat folder. Okay, I'm not actually sure what I should call this class because you can't start the class name with 3ds. So mesh loader 3ds, I guess. Yeah, the class here is called cload 3ds. And then I can just more or less copy paste this here. I think 3ds is like a proprietary binary format, which is why we have this there's a list of magic numbers that we need to scan inside the 3ds format. So that right there is something that I'm glad Linux Air Combat already solved, so I don't have to. Now instead of using those like vector 3 types defined in Linux Air Combat, we can define a new type that uses the GLM types. Okay, so by doing that, we get all these errors because we no longer have these types defined, and whatever these error function helpers are. Yeah, this is just a helper function in Linux Air Combat, so I don't know, I can replace these with just like standard exceptions. Okay, so we have references to the C object and C model types, C color, texture, and vertex. Yeah, the logic for how it loads 3ds files is the most valuable part here, but there's, I need to port all of this over to use new types that aren't, well, I can reuse some of these some of these types, but I need to figure out which ones. Okay, so this C color type can be used pretty much directly. C texture probably can be used directly as well. I want to define my model class to be similar to C model. And then I don't think I need stuff like C sphere, which is just a hard-coded sphere model. You can just have like a data file that handles that. Okay, so the data type here is unsigned car. I don't know why this takes shorts as arguments. But otherwise, this class should be fairly easy to translate to C++. And all of these pointer arguments can just be references Actually, they can be constant references. Except for take, but I don't think we need to actually copy take. Also, since this is just defined as an array, that means we don't actually have names like RGB for the colors. Not sure if we can actually fix that. Well, let's deal with that in a second. Hold on, I have to step away for a second. Okay, I'm back. I just remembered that at least in C, you can use an anonymous union. I don't know if you can still do that in C++. Okay, hold on. This one said that you can still use anonymous unions. At least according to Bjarne Strostrup. The problem is whether you can use an aliasing union. Okay, so if I can use a union here, that would actually allow me to have it defined both as an array and as a set of RGB elements. And also, I think later on I'm going to make this into a templated class. So the uint8 is going to be gone. It's going to be replaced with a template argument. And it also means I can't have a color.cpp file. So everything needs to be defined in the header. Also, until I port this file, I don't actually want to include it in the build. So I need to comment that out in CMake and remove the header file from CMake as well. But for now, let's see if we can actually compile this using the union. I don't remember which header is in which defines memcopy. I hope it's not C-string. Okay, that's kind of annoying. Okay, what did this set color function do? Oh, all it does is copy from some other function. Okay, that's a copy constructor. Well, I'll copy a sign. Okay, I don't think we need to have the set operators or the set functions there. We can just do just construct it in place again if we need to assign a value. Okay, so we can define an equality operator. Why are you comparing colors? I don't know, it's just like a library type, so this will be used some way eventually. And it's been a while since I actually wrote a C++ type like this. I don't remember the exact function signature for a copy assign operator. Yeah, so you just return a reference to the name, or a reference to the type, which is this pointer. Yeah, okay. You ain't gonna need it. Well, I'm gonna write it anyways because I'm basically porting over this type from the existing Linux Air Combat code. So they already have some function is equal, which I assume is used somewhere. Yeah, they do use it a couple of times whenever you're comparing vertices here. I think this is like vertex deduplication, which it does by checking whether the vertex colors and the vertex position are the same. So it is used in a few places where you need to compare whether two colors are equivalent. And since I'm going to be porting this logic later on, I need to maintain this functionality. Okay, using single letter names there is not very readable, so I'm going to change those. Okay, so we have a comparison operator here. Copy assign. We're defining this as a union type. I still haven't checked whether that works. So once we have the color type defined, yeah, we can access individual elements here. So R, G, B, A, and also elements, which is just the array of RGBA data. So these are stored in the same space in memory, so it should be equivalent. So R is equal to element 0. I'm not sure if I should keep this as a C array or switch it to STD array. I think switching it to an STD array is going to be better in the long term. Okay, so we have the color type ported. Right now it only supports 8-bit colors, which is fine. That's basically all you need. Well, since the original engine only uses 8-bit colors, to get equivalent functionality, this is all we need, so that's fine for right now. I suppose later on, if we add more advanced rendering features, we could turn color into a templated class. In which case, this becomes a template argument, and we get stuff like 32-bit colors or floating point colors basically for free. Like we have to pay the compile time price for that, but we still get the functionality equivalent to this for free. But okay, so we ported over the color type. The texture type, this basically just wraps an OpenGL texture, and he puts, I don't know what all these values do here. Wait, to use a texture, it must be loaded and added to OpenGL texture list using GL gen texture instead of this class. So why does this function even exist if you're not supposed to use it? Okay, so GL gen texture calls this function internally. That's kind of awkward, but that should be easy enough to change. So we should be able to port this texture class pretty easily over to the new system. Okay, it stores the name of the texture directly in the class. MIP mapping. Okay, now this is interesting. Average of the texture's overall brightness. It's going to require some pre-processing on the CPU, I guess. Okay, this is used by the land rendering function. Okay, so when you create the texture, it's set to 1 automatically. Okay, this is kind of weird. This isn't the hardest thing to port over, but it's kind of weird that we need to do this in the first place. So this is basically the average brightness value of the texture, which is just stored as like part of the metadata. Now, are these red, green, and blue functions used anywhere? Also within the land rendering function. Okay, yeah, so this is just metadata that's used for terrain rendering. Texture quality. Yeah, it's part of the gen texture TGA function. It does not appear to actually do anything. Let's see, so quality is the second argument. It's set to 0 here. It's set to 0 on all these function calls, except for, okay, some of these are set to different values. But as far as I can tell, this quality argument doesn't actually do anything. and the alpha blending is set on the texture. That's fine, I guess. We could probably move that to the material instead of being on the texture. Okay, but mostly this class just stores the texture ID of the OpenGL object. And I guess stores a CPU copy of the texture data as well. Those are the main things we need. Everything else here, like width and height, that's metadata that's easy to port over. Oh, and a function to sample the texture directly. Okay, so that should be fairly easy to port over to our new engine. We're going to add a texture class here, then an OpenGL texture. Oh, wait a minute. I need to actually save these changes in Git first. Okay, and before I actually make the texture class, I want to do some like bookkeeping changes here. I want to change the name of all these files from OpenGL to just GL. Because OpenGL is just too verbose. That didn't actually change anything. Oh, it changed stuff in every other file except for this one. Amazing. Thank you, Visual Studio. Okay, then we can change the name of the file itself. Automatic renaming is wonderful when it works correctly. Yeah, Visual Studio works correctly when you're writing C# code, but I guess when you drop down to C, C++, and you have all these header files, it just becomes impossible to do renaming automatically. Actually, I think it is actually impossible to tell whether a symbol is being used in C code or C++ code, just because you have the preprocessor that can change basically everything. So whatever. We just have to repeat this process for every single file now. Oh, is that why I didn't do it? I didn't actually read the dialogue last time. Okay, so it still didn't work. Okay, so I think I renamed the files. Oh wait, no, I need to change the name of the includes in these file definitions too. Oh look, that one worked. Can mangle things pretty badly sometimes. Yeah, Visual Studio is very good at mangling your code if you just point it at stuff without thinking. I can't decide if I should use Vanilla.js with WebGL or Godot when I'm writing my flying game. It's just going to be a hobby project. I mean, the best advice there is to use whatever environment you're most used to. So if you use JavaScript, if you know how to write JavaScript, then you should write it in that. If you know Godot already, you should use Godot. And you can also use it as the learning experience if you want to learn the new environment as well. So ultimately, it's up to you. Control-Shift-H, replace all. Yeah, that sometimes works. It's not always the best way to do it. And also, I don't know if that works across multiple files, but I definitely don't want to risk that. I'm more comfortable in Godot, but you want to do it on the school Chromebook. Well, if that's I mean, I don't have any experience programming on a Chromebook, so I can't tell you what would even be good on that. But if that's the environment you have, then I guess you have to just stick with the tools you have right now. Okay, so I think I renamed most of this stuff. Let's just follow the errors. That's the fastest way to find what you haven't changed. Okay, way too many files open. There we go. Okay, so that should be every instance to the old names. Yeah, we're compiling successfully now, so there we go. All right, so now we need to actually store those changes in Git. Godot has a web editor. I mean, like a website you go to where you can actually like make a Godot project. That is pretty interesting. I don't know. I've never used Godot engine or really any kind of web development for Gamedev. But I mean, hey, you should try it out, and if it works, then that's your entry into the game dev industry. Okay, now we can make the texture class. Okay, so textures are kind of interesting because not only do you have to worry about the render backend, but you also have different texture formats that you need to account for. So that's basically like a table for every texture format and every render backend. But in practical terms, right now the only textures we have are TGA files. I would like to add stuff like ping or BMP later on. Okay, well, I mean, that's probably just going to need extra classes to represent the underlying data. And also, it's going to be optional whether or not a texture is even loaded on the CPU or on the GPU. So I need to handle both of those. Okay. Shouldn't matter, it's a blob, right? Yeah, I guess if yeah, I don't need to store raw data for the texture. So it should just be RGBA data. That yeah, you're right. Okay. But I do need like multiple functions to represent like load from TGA or load from ping. But those are just utility functions, I guess. Yeah, okay, so the public interface is going to have something like, it's going to be static functions like load from TGA. And then internally, that's going to return a new texture object. And it will also call the texture constructor internally. Okay, so we can optionally store some texture data on the CPU, which we're going to store in M local data. Then we also need another pointer here for render data, which represents the data that's loaded into the rendering API. So OpenGL, for example. One or both of these can be set at runtime. Because conceptually, you can have a texture that's mostly used to be read and written on the CPU. And they are using like CPU side texture reads in Linux Air Combat, so we need to support that. Then we need to actually make a new texture class here as well for a GL texture. Isn't that just a bind and load to the GPU? Yes. So that's basically this GL texture class is just going to store the handle returned from OpenGL. And then optionally, we can also have the CPU side local data for the texture. Okay, I just try to move this include, but I actually do need it because it's used right there. Okay, anyway, so we need to then add the functions here to load and unload texture objects. And just like load mesh, we need to actually create the GL texture and then populate the data and then make the OpenGL calls. And then also, yeah, set the render backend for the texture. So I need to add that as well. Okay, we need to find the GL texture class. And as far as I know, the only actual data that needs to be stored here is the texture handle itself. And again, I'm going to use learn OpenGL as the reference here. Okay, yeah, OpenGL texture parameters like the filtering and the, what's it called, the mirroring, the sample format. Yeah, the wrapping function, that's all defined on the texture object itself, but I don't think we need to store any of that. Yeah, basically you just need a gen texture, bind the texture, text image 2D, and possibly generate bitmaps, and that's it. The actual part that we need to store is just the texture ID. Are there minimum hardware requirements for this game? Linux Air Combat says that it can be run on very low, like very low hardware specs. So the game itself is very simple, and they claim it can run on a Steam Deck and a Raspberry Pi. And those are two goals for, like, I want to maintain compatibility with those systems, but also add some more like optional modern features. So possibly on a Raspberry Pi, it would remain the same level of quality here, but if you run it on a desktop, you can add more advanced features too. And basically, the only hardware requirements are that it supports like OpenGL 2.0 or something. And that does not require very much memory at all. So if it runs on a Raspberry Pi, it can run on almost anything. Okay, yeah, so we just store the textures here. We need to set the render data on the texture itself. Set render data. Oh yeah, we need to set the render backend. And then we can call that. Okay, so I need to, yeah, I'm adding the meshes, like the actual unique pointer mesh, or unique pointer lives in this meshes array. So I need to create one of these for textures as well. Depends if you want to direct bind to GPU or cache in memory. I'm not sure what you're talking about here. What do you mean direct bind? I can tell you that what I'm planning for right now is to pretty much always store the GL texture on the GPU, and only a handful of times when you need to actually retain it on the CPU. But for maximum performance, the texture is going to live on the GPU. Okay, so we create the texture, we gen texture. That means that to unload the texture, we need to get the texture data. then delete texture for the stored ID. Okay. The other thing I need to figure out is how to remove meshes from this vector. Because when we get to the unload mesh, all we have is like the pointer to the mesh object. And we need to use that to find the unique pointer in the vector. Now, I don't want to do something like a linear scan through the entire vector, but all right, this feels kind of dirty, but the only way I can think of is actually storing this in a unique map. Or not a unique map, an unordered map. So I need to actually include that type here. We're just going to map from a geo mesh pointer. It's going to map from a raw pointer to a unique pointer. Now that seems incredibly dirty. Like, this does not feel like a good way to actually get this functionality. Especially because unordered map isn't actually all that fast. But I can't think of a better way to do it right now. So instead of emplacing back, what? Okay, I don't remember the correct way to construct a new element in this map. And these type signatures that Visual Studio is giving me are just completely inscrutable. Okay, yeah, we have insert or in place. Okay, yeah, in place should work here. Okay, since we have this unordered map, which takes the raw pointer and maps it to the unique pointer, I'm instead delete the entry from the array. All we need to do is get the pointer to this object and delete it. Okay, so that handles the memory allocation and deallocation for these GL texture objects. You need to actually do the rest of loading the texture. So according to learn OpenGL, bind texture. Oh, I put them in the wrong place. Okay. Okay, so we create the texture ID, we bind it to the texture 2D slot, and then we can actually call GL text image 2D to load data from the CPU to the GPU. Level is the bitmap level. Internal format. GL RGB. Okay, so I guess internal format's going to be part of the format that we need for. Yeah, okay, we need to actually create a definition for the format here. Like RGB or RGBA? Yeah, exactly. So most of the textures are probably going to be RGB, and some of them are going to be RGBA. So we need to support at least those two use cases. And then we need other metadata like width and height. Okay, so once we store the texture format in the texture object, we can use that to determine which texture format to load into OpenGL. Yeah, so this switch statement just translates it from our enum format to OpenGL's enum format. Okay, I don't know what border means. Here it's set to 0. A GL RGB. Okay, there's two different parameters here that we need to OpenGL. Okay, first of all, border is set to 0. I think that's like a deprecated parameter. We have internal format and format. And at least in this Learn OpenGL example, they're both set to the same value. I don't know any case where you would want those to be different. Okay, so internal format is how we store it. Okay, so the second format is the data that we're loading and the data type. Okay. So that's going to be the same format for now. And the only data type we support is uint. Uint8, which is going to be equivalent of unsigned byte. And then we can actually send over the data. Okay, so if we don't match one of these specific values, this is going to lead to an invalid format for OpenGL, but I don't really want to handle that case right now. But anyways, we have generate the texture, bind texture, and then load the image data. So that should be good enough for our purposes right now. Why use local data and not just have it as a param for load texture? I'm not sure what you mean. What do you mean a param for load texture? Oh, you mean adding a param right here? That's possible. But the API I want to make has there are use cases where someone's going to take this texture class and get the local data and manipulate it, like reading from it or writing to it. So we already store the local data in the texture, and we may as well just use that as the way to populate this argument. Okay, the other function they're using is GL generate bitmaps. Let's just go ahead and copy paste that. Okay, that should be enough to actually load the texture into OpenGL. As for deleting it, I'm not sure if there's anything else we need besides the delete function. Okay, interesting. There's no use of the delete function in here. Well, whatever. We called it correctly on our end. I don't think we need anything more than just this. So that handles loading textures onto the GPU. But before we do that, we actually need to load textures directly into CPU memory first. And actually, I don't think this should be a static function. I think it should just be a standalone function. Okay, so as far as I know, TGA is a pretty simple format. And there's probably very little that we actually need to do to port over TGA code. Okay, so this is from Linux Air Combat. Just loads the file data. Doesn't SDL have texture loading capabilities? Yes, but what I'm looking at right now is this function where they have this this parameter alpha type. So this is specific to Linux Air Combat, and it likes pre-processing their alpha data in the texture based on all of the other like color data. So I'm not actually, we need to port this functionality over because all of the other systems assume that alpha type can be set here. And probably the load TGA function in SDL is going to be not much more different than what's already here. So we can actually port it to the SDL function, but we need to handle this alpha type parameter. Ew, yeah. Linux Air Combat wasn't, I don't know, some of the decisions they made and how they designed their graphics and engine functionality, it's really weird. And like, in order to port this over to OpenGL or modern OpenGL, I need to like preserve the behavior, and then once we understand why it's there, we can remove it later on potentially. But that means that, yeah, step one, we need to write basically the equivalent function for our engine now. Let's see, quality and then alpha type. So quality 0, alpha type is set to -1 here. Which is not one of the recognized functions. I don't like how these are hard-coded alpha type values. Over here, they just set it to 1. And all these other ones, they just set it to 0. Yeah, this is the data that we need to basically port over. okay, so long term, I want to eventually put these functions or put these parameters into like a JSON file, so we don't have to hard code it into the source code. So basically, they use TGA without 32-bit alpha with a mask. I think in some cases they just port the alpha over directly, because like one of the function calls sets alpha type to -1, which is not covered by any of these if statements. So I think in that case it would just result in alpha type being not modified as it's loaded. But again, we need to handle all these existing use cases where we set the alpha type to something else. Okay, so I think first we should create an enum that represents this alpha type. So we aren't just having to compare these hard-coded numbers. Okay, anyways, yeah, let's create the enum right here. Okay, so for alpha type 0, it's like adding the data values, comparing it to 30, and then using that to select between 0 and 255. That's like creating an alpha mask based on the pixel brightness. And we have the next one is max color. Mid color times 6 or 0. This is incredibly specific. I don't know why you would define it this way, not just have the alpha set in the texture. So this is just a really weird way to handle this data. Actually, you know what? I'm not sure if TGA files actually support alpha. Okay, so the type it supports is RGB grayscale. Okay, so yeah, TGA should support alpha. Well, the ones that they are included with Linux Air Combat does not include the alpha format. So that's why they're going through this weird loading step. So yeah, we do need to port this functionality over in order to maintain the correct texture rendering. So mid color times 6. Okay, so alpha equals red and then color equals white. That's really weird. red times 2 and color equals black, or red and black. Yeah, this is absolutely horrifying way to define data. Okay, so we need to actually store the alpha type on the format, or on the texture, next to the other metadata. Okay, so yeah, like you mentioned, I think SDL has functions to load TGA files. Yeah, under the SDL image library. Oh, this is a different library than SDL itself. Okay, so if we're going to use SDL image, we need to add this to our package list. Also, I want to take this load from TGA file and put it into a different file. Okay, so CMake and Conan are running in the background, I think, to load all the new, well, to compile the new package I just added. No, I need to add like a copy constructor and move constructors for the texture. And I don't actually want to write a move constructor, so we're just going to delete that function. Okay, actually, it appears Conan was got stuck on some function. Because I think I canceled it halfway through, so I need to fix that. Okay, so we can actually start writing the load from TGA function. So texture alpha type is going to be just passed in as part of the argument here. And file name is just going to well, I mean, that's the name of the file, but I need to load this in with something that SDL can recognize. Yeah, so looking at the files, they are alpha value textures and masked textures. Looks like premature optimization to save space. TGAs can be BGR format. Yeah, I'm not sure exactly what format the TGA files that Linux Air Combat is using. But for right now, we're just going to copy their import process directly. And I think their code already handles whether or not it's BGR or RGB. By they, I mean both SDL and Linux Air Combat. Okay, so once we actually have SDL image, we need to figure out how to use this. SDL3. I'm not using SDL3. Okay, so anyways, SDL load uses the SDL surface format. Yeah, I really do not want to copy over their TGA loading code. So I think using SDL surface or SDL image would be the best bet here. Okay, so the TGA format is going to, or the TGA file already has its own pixel format, which is going to be stored in SDL pixel format, and then we need to read this and use that to populate the metadata, so texture format basically. Then of course we get the width and height from here. The pitch is kind of important, and pixels. Okay, if the row pitch of this image is not 0, I don't know how OpenGL is actually going to handle that. Because we're basically just going to be copying the pixel data into here. pixels is what you dump into the OpenGL side. Yeah, I understand that, but if the pitch value is non-zero, I need to figure out how OpenGL will handle that, or even if that's a case that will actually happen. I think the pixels are going to be tightly packed and we aren't going to have to worry about pitch, but I don't know. Okay, anyways, let's just create the texture object for right now. Okay, so I just need to make a couple more constructors for this. Okay, so for these two values, we need to actually change ownership of them. But for everything else, they can just be copied. Okay, so from that texture we just created, or that constructor we just wrote, so we need to load SDL surface and then read the actual texture format and the width and height and the other metadata. Do you think the 3ds files are just raw 3D Studio Max files? I think they are. That's why inside the 3ds loader function that comes in Linux Air Combat, there are just a bunch of magic numbers here. So I think they're just reading from the binary. Like I looked at the files, they are binary files, so I can't inspect them with a text editor. So I really do think they're just loading raw 3ds Max like modeling files. So again, I would like to like write an import function to turn that into a GOTF or something similar eventually. But for right now, we're just directly loading from the 3ds files. Okay, so we need to create the texture format. Okay, why am I not getting any autocomplete on this? It's a little bit annoying. Okay, I need to figure out which TGA files they actually use here. They only support RGBA or RGB and grayscale, so they don't actually have too many formats here. And I don't know what they mean with grayscale. Grayscale is only 8 bits, so I guess that's going to be index 8. Yeah, grayscale equals single channel. Yeah, so they have it, they have grayscale 8 bits, so I assume that's going to be the same as index 8. I don't actually know if that's a good assumption. I don't know what SDL means by the index format. Okay, so we need format, width, height, and alpha type. Okay, I don't know why these just causing a bunch of errors. Specifically why this is causing an error. Okay, I have no idea what this error means. Type name is not allowed. Oh, okay, I figured it out. I need to use the colon, not the dot. You did it again. I'm not yet through stream number 2. Yeah, I am doing this a bit irregularly, but plan to do it probably every weekend from now on. I can open the 3DS files in Blender. Should be easy to convert them to GOTF. Yeah, I hope so too. So that's like one of the goals is to write tooling so that part of the build process it loads the 3DS file and converts it to GOTF, and then the actual game engine just loads GOTF directly. Okay, so we created the texture object here. Now we need to actually load the data from SDL into the texture. Okay, so once we need to actually create the pointer or the array that's going to store the local data. Uh, okay, so what I wrote right here is that we just accept any data from the user. I actually don't want to keep it like that. Okay, so we're going to use this create local data function, which will allocate memory, and then we can release it later on with release local data. Oh, I also need to add a destructor here. Okay, so since we're just going to create the memory for this internally, I think this should actually be a unique pointer. Okay, then once we need to create the local pointer by allocating an array with set with a make unique. Set local data with surface pixels. I don't want to do that because surface pixels is owned by SDL. And we're going to free the surface right here, so that's going to become invalid after this function call. We need to copy it to our own buffers and then release the SDL buffer. So to actually, the buffer we're going to copy this to is going to be a unique pointer array. Actually, it doesn't even need to be a unique pointer. It can be a vector of character. C++ knowledge is limited, work mostly in C sharp. Yeah, I do a mixture of C++ and C sharp, and I gotta say C sharp is very nice in pretty much every case except for performance. Like you can get good performance out of C sharp, but the reason like I'm doing this project to begin with is because I want to get practice doing C++ development in a fairly complex project like game development. So yeah, stuff like memory allocations and memory lifetime is something you need to keep track of when doing C++ and C development, like the memory lifetime of the SDL pixels buffer. It's just like a pattern you have to get used to every time you uh, load data using a C++ library. Okay, so we actually need to calculate the size of the image data that we need to store. Oh yeah, by changing this to a vector, we need to remove all this initialization code. Isn't it the size of the pixels thing? That is true. I'm not sure if this actually tells you the size of the pixels. Just mem copy that. Yeah, I do want to do the mem copy eventually, but okay, yeah, we have bytes per pixel here. I don't think the SDL format actually says exactly the size of the array, but it should be tightly packed. And hopefully that means that pitch is just equal to the size of each row exactly without any like overhang. So then we could just calculate pixels, which is width times height times bytes per pixel. But we need to actually get the bytes per pixel value here. I don't think we're going to read from that directly. Instead, we're going to calculate it based on our game engine's texture format. Can confirm it is indeed tightly packed. I think pitch equals padding. Indeed, it's hopefully it's 0. Well, I think pitch should be equal to the row size if it's like tightly packed with no extra padding at the end of the row. So pitch should be equal to row size plus padding. It doesn't actually say in what case this would be different then. Yeah, hopefully pitch is exactly equal to W times byte size. But anyways, if that's true, then we should be able to load a TGA file from SDL directly into our internal buffer here. Height times pitch is the size of the surface's whole buffer. Yeah, that makes sense. Okay. Although the reason I'm writing this function like this is because we're going to be calling, we're loading the width and height of the texture and the format into the texture, but we're not actually going to pass the size into it directly. So getting the size of the data directly from the SDL surface, we can't do that. We have to calculate it from here. Okay, since local data is now a vector, we don't actually need to write a custom deleter function. Let's see, so render backend is just a pointer that's non-owning. Vector has its own deleter. And render data is going to be deleted by the GL backend, which is right here. So we don't actually need a destructor on texture anymore. Okay, so yes, so this is the pattern I'm trying to do here. We call the create local data function, and then we mem copy from data pixels into pointer. Okay, I want to add this function here to get the size of the local data. Okay, so like we were talking about, I'm not sure if the pixels buffer in SDL surface is going to be the same size as the vector that we're creating in texture. So I need to add like some kind of runtime assertion that these are the same, or not an assertion, but like an exception, I guess. it should be the same, and I don't really have a way to handle the error, but we're just going to throw an exception. Why pass the data and size in create local data? What are you referring to? Like, why are we not passing the size? Because I want to create it from width and height in this format. Like, not every texture is going to be created from TGA, and not every texture is going to have an SDL surface that we can read from. So we need to create the internal buffer based on the height, the width, height, and format of the texture itself, without relying on an external source. Because in theory, you could also just do it where you create the local data, and then you write directly to it without having an SDL service to read from. And it should be the same size, but I'm not exactly sure if that's the correct way to do it. Okay, I don't know what that suggestion, if that's even a good idea, but we're just going to ignore it. Okay, so that compiles that. Let's see. We need a way to actually test this is loading a TGA file correctly. Now, I don't want to add that exactly to the main function here, but we need to write like unit tests to make sure that loads correctly. Hold on, let's just commit this for right now. Okay, then the benefit of making this engine into a separate library is that I can create like a unit test that actually runs the engine. Take one of the LEC example textures. Yeah, that's exactly what I'm going to do right now. So right now, this testing, we're running model viewer. We need to create a different thing here. No, not a file. We need to create another program here that tests the TGA loader. Okay, so now that we need to create this data folder here. And then we can load our test data into this folder. And like you said, we're just going to load some of these test data, or some of the texture data from LAC into this test folder. Okay, so we're going to call the load from TGA function, call it on cactus1.tga. And the alpha type that we're using is going to be none. And this by itself should run to completion without doing anything. No, we have some linker errors. Okay, so it's not finding this class for some reason. Okay, it might be because of this using statement. Okay, yeah, that was the problem. Okay, so once we have that, we can actually test this with TGA loader. Okay. I need to load the proper data file there. Okay, there we go. So we are hitting a size error. Okay, so the format we're loading from the TGA file is whatever this inscrutable number is, 3900.76419, which does not match any of these pixel formats. Oh my god. Okay, so this is defined using macros. Bytes per pixel is 3. Is it BGR? It could be. So again, I need to see what the actual definition of these files are. So BGR 8888. It's not the same number. Okay, it might be that this format is like invalid, and it's not going to be equal to any of these values. Okay, let's add this to be the 0 value. Okay, let's see if this value itself has anything on the internet. Okay, so someone else has gotten this value before, but it doesn't appear to be linked to anything. Okay, somehow that forum post is exactly the same as the one I just read. Okay, so we know that it has 3 bytes per pixel because that's what the format says. Yeah, 64 by 64. Pitch is 192, so it is tightly packed. I just don't know what this actual format value means. Look at pitch. The pitch should be correct. This should be tightly packed. So 64 times 3, that equals 192. I just don't know where this format value itself is coming from. Okay, so SDL has this function get pixel format name. Okay, so it is BGR24. Okay, so you were right. I don't know why that I didn't see BGR in here earlier. Okay, I just wasn't looking at this particular one. So BGR24 is going to be, yeah, so that's 24 bits per pixel, 3 bytes per pixel. That means we need to actually include the BGR data as one of the formats we support. Okay, so if we're going to add support for the BGR format, pretty much the only difference is that we need to expand the get local data size. And that actually should work now. Well, okay, we also need to add it to this loader here. Okay, hold on. So BGR has 24 here, but RGB has 888. I don't know what the difference is between. Okay, so RGB 888. Packed order X RGB. Okay, so I don't know what that means. I think that this one should also be RGB 24. Okay, so at least adding BGR24 there should allow this to load the TGA correctly. Okay, we're getting a different error now. Okay, so some kind of error happened in the texture destructor, which we don't even have a custom destructor yet. Or we don't have a custom destructor anymore. So I'm not sure what kind of error would cause that. Okay, so this value is not being passed out of the load TGA function correctly. Yeah, this is invalid for some reason. Oh, I'm not actually returning it out of this function. That's why. There we go. Okay, so we loading the data 64 by 64, the BGR. The size is whatever those values multiply out to. And it looks like this is loading correctly now. All right. Okay, so that allows us to load TGA textures into the CPU local buffer. But after that, we need to actually load the data into OpenGL. Let's see, we have the vertex data in the mesh. That means eventually hold on. The model loader needs to actually include textures and meshes. Again, we can copy that from the LAC folder. Although based on these file names here, I don't think there's actually textures for the planes. I think the models only have like vertex coloring on them. Okay, so we have textures like cactus, flare, gravel, smoke, tree. I want one of these that actually has both textures and meshes. Might be that they don't use any textured meshes at all. In which case, the only thing we need to do is load the vertex colors from the model. Like stuff like trees and cactuses might just be like billboarded textures placed on the terrain. Okay, let's take one of these model files, A6M2, and put that into the model viewer data. Okay, so we wrote the texture loader here. We need to actually, okay, we have meshes. We need to write a way to load the mesh from these model files. And that means the mesh actually consists of, well, okay, the model file needs to be loaded into a model object, which includes a mesh and a material. So those are the next things I need to write. I already have material here, which contains nothing. I need to write a model class as well. Yeah, so this is what I already wrote before. It's just a list of meshes and a list of materials. And then we need a way to load a model from a file. Looks like they don't have material textures on first glance. Yeah, that's what I was thinking too. Okay, so this is where I actually started today, and I was planning on writing the model loader. Uh, Instead, I wrote the texture loader. But I think I'll leave this for another day. I'm going to end the stream today after writing the texture loader. So next time, I'll try to write the model loader and try to get the 3D mesh rendering working. But thank you for joining today. Learned quite a lot about OpenGL and SDL too. Like I said, I'll try to do streams probably on the weekends or on Fridays. And I do announce it. I try to like put the stream up maybe an hour before the stream actually starts, and I'll also announce it on Twitter as well. So if you want to join next time, you're going to have to follow me on YouTube or Twitter to get the notification. So thank you for joining today, and I'll see you next time.